Hello and welcome to the second lesson of the Statistical Analysis Unit, Measures of Spread. So there are a couple of measures of spread that you should already know. The first one is range. Range is a number and that's calculated by working out what is the highest score and take away the lowest score. The interquartile range, something you've met previously in Year 9, Year 10. The interquartile range works the same way, but it is the upper quartile, sometimes called Q3, minus the lower quartile, sometimes called Q1. Once again, it's a number. It's not a thing that says it's from this to this. It is one number. It's the difference between Q3 and Q1. What we're also going to look at is what's called standard deviation. Standard deviation, it can be a little bit tough for people to get their head around, but the idea is it's the mean distance from the mean, which is kind of odd, but it basically means on average how far away, if you were to measure the distance between one piece of data and the mean, add up all the distances away from the mean that there are, and then work out the mean of those means, mean of those distances, what would that be? The way that measures spread is if all the data is very close to a mean, kind of if you imagine this graph, any one piece of data along it at the end, it's not too far away from the mean being this bar. So we've got very small distances to get to the mean, like this. If your data is very spread out, you would have a curve, frequency curve, that looks something like this. If the mean was here, you can see that if you pick one piece of data somewhere along the curve, these average distances to the mean are going to be much greater than the one above. So that's what standard deviation is measuring. So in the very first lesson, we introduced a couple of symbols. The first one is sigma x, and the x is just a little subscript to say that we're giving the pieces of data the variable x to represent them, and then the sample standard deviation is sx. Once again, the x is just the variable we've given to all the pieces of data. So remembering the difference between sigma and s is really important, especially if you have a Casio calculator, as what these do, these match with the symbols that your Casio calculator is going to use. So knowing the difference between population, sample standard deviation, really important. The next part of your book just covers what is meant by the word quantiles. Quantiles is an overarching term for ways we can divide up sets of data into set different amounts. So in the first tab we have got what are called quartiles. Quart kind of replaces the quantity bit, so the quantity is the first part of quantiles, an amount, dividing into an amount. Quartiles means dividing into quarters, that's why we start with quartiles. So as you can see below, divides it into 4 equal parts. The first quartile is 1/4 of the way up, so it's the first 25% of the data, sometimes called Q1. The second quartile is 2/4 of the way up, 2/4 is 50%. The third quartile, actually this should read 75%, so if you just want to change that. And that one's sometimes called Q3. Q3 and Q1 were important because they are what let us calculate the interquartile range, which we'll be coming back to. Deciles, dec for 10, so we're dividing something into 10 equal parts. The first decile is 1/10 of the way along. 1/10 as a percentage is 10%, so on and so on. So the fifth decile, 5/10, 50%. Ninth decile, 90%. The last one that we're going to use in the course is percentiles. So percent means out of 100, so it divides it into 100 equal parts. The first percentile is 1% of the way up, nice and easy. 22nd percentile, 2% of the way up, and so on and so on. Usually it's just a counting thing. So if you're looking to divide something in deciles and you've got 20 pieces of data, the second decile would be 20% of your 20 pieces of data, which will be fourth. So whatever the fourth piece of data is in the list of 20 items will be the second decile, the 20% along the way. So those ones are quite simple. Usually it comes with graphs, and we'll have a look at graphs later on. Okay, so finally we are going to run some calculations. And what we're going to look at is how we can calculate some of these measures of spread. Not all of them right away. So in order, I have put the number of points that the 10A League soccer sides got in the 2017-2018 season. Lowest was 20, the highest was 64, and we've got some others along the way. So we need to calculate the range, the lower quartile, the upper quartile, the interquartile range, and then finally the fourth decile. Okay, so let's start with the range. The range, very simply, is the highest score, 64, minus the lowest score, 20, which is 44. So to calculate Q1 and Q3, we first actually need to calculate the median. And it doesn't make that explicit in the question, but it's part of the process that you have to be able to follow. So quick refresher, how do we calculate the median when we have got a list of numbers? So what we said was the median has a position equal to, so let's put median pos, equal to halfway between the first piece of data and the last piece of data. So when there are 10 pieces of data, it's halfway between the first piece, piece 1, the last piece, piece 10. How do we find half of it? Divided by 2. So that is 5.5. So the position of the median is that it's the 5.5 piece of data. How does that work? Well, we can't really have a piece of data that's in position 5.5. So what we do is we take the position, the figure that's between the fifth and sixth piece of data. So if we count up 20, 21, 32, 33, 35, that's our fifth piece of data. 39 is the sixth piece of data. So our median is in the middle of these two. So the median in this case is halfway between 35 and 39. So add up 35 and 39, then divide by 2. So our median is 37. Okay, how does that help us? Well, the lower quartile, put simply, is the median of the list that's to the left of the median. So we've got the median of 37. On the left of the median are 5 numbers. We go from 20, 21, 32, 33 to 35. We find the median of those pieces of data, that will be our lower quartile. So we've got 5 pieces of data. With 5 pieces of data, 1 plus 5 would be 6. Then divide by 2 is 3. So it's the third piece of data. So we count from the left, 1, 2, 3, we get to 32. So 32 is our lower quartile. And we can do the same thing with the list on the right. It'll be the third piece of data in the list. 39, 41, 43 is Q3. Once again, some people prefer just to cover up the numbers until they've got an equal number on either side. You can do that as well if that works. This is the sort of mathematical definition that you'll see the most often. The idea of the position is halfway between first and last. So Q1 is 32, Q3 is 43, which means that the interquartile range, which I will shorten to IQR, is the upper quartile, take away the lower quartile, which gives us 11. Okay, so the fourth decile then. The fourth decile is nice and easy when we've got 10 pieces of data, because the fourth decile is the piece that's 4/10 of the way up, counting from the bottom. When we've only got 10 pieces of data, 4/10 of 10, it's nice and simple, that's just 4. So if you look for the fourth number in numerical order, just change colours, you can see that that is 33. So the fourth decile is 33. In general, the position of it, when I want the fourth decile, is 4/10 times by how many numbers are in the list. And remember, if it is a percentile, it wouldn't be out of 10, it would be out of 100. If it wasn't the fourth decile, if it was the sixth decile, it would be 6 out of 10, and so on. But that's the position, it's not the value of the decile. That just tells you where to look in the list. Make sure you understand those distinctions. Okay, so we've calculated some of the measures of spread, not all of them. We'll come to standard deviation next time. So for now, in the exercise, these specific questions, pick out the questions on measures of spread that aren't standard deviation, and those are the ones you should attempt to check your understanding.